Hello everyone, hope you are having a nice day. Today we are going to discuss about simplified instructional computer, extra equipment. So in the previous classes, we have discussed about what is system software and the way to learn the system software. So in today's class, the main objective is the students will be understanding the basic concept of SIC, XC, and you will compare, specifically you will compare how SIC has a relation with SIC, XC, then the various registers supported by SIC and the instruction set, then how a read and write operation is performed in SIC. So the lecture goes like this. We'll be learning about memory, we'll be learning about registers, we'll be learning about data formats, instruction formats, instruction sets, input and output. So before going into this, we have discussed about what is system software. What is system software? So it's a software that works internally inside the computer. It is not run by humans, or the user cannot run this system software, but system software helps the user to run an application program. For example, you are running a C program, you will type the code, that is the work of a user, then you will try to compile. At that time, system software comes into picture. What does system software do? It's a language translator. Compiler is a language translator which converts our high-level language or C language into a machine understandable form. What does machine understands? Machine will understand only two things, zeros and ones. It cannot understand your code. It cannot understand, for example, if I am typing a word like int a, I can understand the meaning, that is I have declared a variable called as a of type integer, but my computer cannot understand. My computer understands only zeros and ones. So what I have to do, there should be a compiler, and I cannot understand computer's language. So in the intermediate position there is a compiler, which is nothing but a system software which works internally inside the computer, and what it will do, it will convert my language into zeros and ones. So that is what is the work of a system software. System software helps to work internally inside the computer for the benefit of the user. So we have different system software. Operating system is a system software. Say operating system, so you can have hardwares, you can have a computer, you can have a CPU, you can have a keyboard, you can have a mouse, you can have an electrical connection to that, but it will not work. Only when you have an operating system installed into your computer, it will work. Otherwise, it's just physical parts. The physical part it will never function. That it will just be like that. So system software helps us in many ways. So to learn the system software, you have to learn the computer. Physical computers has to be learned. But here, it is impossible to learn a real-time computer, because real-time computers instruction sets are complex, and we have discussed about that. So since those are complex to learn, we are creating two imaginary computers or hypothetical computers. So the first hypothetical computer we learned was simplified instructional computer. So what is meant by hypothetical? Here, for example, I'll put in this way. Consider you have a AutoCAD software. In that AutoCAD software, I'm designing the building. So once the entire design is over, the design looks like the building, but it is not actually the building. You cannot go and stay there, but you can see how the room will be, what will be the height of the room, what are the structures that are elevated, where we'll keep the windows, how the windows will be there, how the design will be there. We can see all those things, but you cannot use that because it is just an imaginary drawing. It's just a design. Similarly, simplified instructional computer is an imaginary computer which has all the components of the real computer. It has memory, it has registers, it has data format, it has instruction formats, and all those things. So the first computer we learned in the previous lecture was simplified instructional computer. In today's class, we are going to see an upgraded version of SIC. That is an upgraded version of SIC. That means, for example, you have a mobile, you have an Android OS. So every now and then we will get an update. What is meant by update? That means it will be better than the previous one. For example, you have a mobile phone. Suppose you have an iPhone. Initially you had iPhone 4, iPhone 4S, iPhone 5, iPhone 10, now it's iPhone 12, iPhone XS. That means what? For every update, there will be some extra things. So the latest one will have all the features of the previous version and also some extra features. You might have learned this thing, that consider there is a father and son. Father will have some characters. What will son have? Son will have all the characters of father plus some extra character. So similarly, this SIC and SIC-XC are designed to be upward compatible. What is upward compatible? The program that runs in SIC will also run in SIC-XC, but some programs that are specifically designed for SIC-XC will not run in SIC. That means the programs that are designed only for the upgraded versions will not work for SIC. So that's the thing. So we have discussed till this one. Now we are going into the lecture. So the first one is memory. So what is memory? Memory is nothing but where we use for storing things, storing data and all those things. And here in SIC we have discussed that the memory is of 8-bit bytes. What is 8-bit bytes? 1 byte is equal to 8 bits. So 3 consecutive bytes. We have also discussed that 3 consecutive bytes form a word. What is 3 consecutive bytes? First byte, second byte and third byte. So you should not confuse in this way. That is first byte, fourth byte and seventh byte. There are 3 bytes, but 1, 4 and 7. They are not consecutive bytes. So 3 consecutive bytes form a word. 1, 2, 3 or 2, 3, 4. So consecutive bytes form a word. So in SIC we have discussed that the total memory available is 2 power 15, that is equal to 32,768 bytes. But in here in SIC-XC, since it is upgraded version, the total memory available is 2 power 20. That means 1 megabyte of memory. So from SIC, which was 2 power 15, now the memory has increased to 2 power 20. So we have discussed about memory. What is memory? And here the memory is divided into 8-bit bytes. So 8-bit bytes is 1 byte is equal to 8 bits. Then 3 same structure as in SIC, that is 3 consecutive bytes form a word. And here the total memory available is 2 power 20 bytes, which is equal to 1 megabyte of memory. Next, we'll see about registers. In SIC, we have discussed about 5 registers. You might remember that the 5 registers are accumulator, A, that is accumulator, then X, that is index register, then L, linkage register, PC, program counter, SW, status set. So we have discussed 5 registers and each register has its own functions. Here we have 4 more registers. The 4 registers are B, S, T and F. B is nothing but base register. It is used for base relative addressing mode. Then S and T are general purpose registers. S and T are general purpose registers. That means they don't have a specific purpose. The last class we have discussed about accumulator. Accumulator is a register. What is the function of accumulator? When you are performing some arithmetic operation, the values, for example, you are performing an addition operation, you will get an output. Before the output is stored in a permanent variable, the output will be stored in a temporary variable for a certain duration of time. At that certain duration of time, that output will be stored only in the accumulator. Accumulator is a temporary storage for arithmetic operations. Maybe it's an addition, subtraction, multiplication or division. For that matter, whatever is the arithmetic operation, we will be using accumulator. Then in the last we have discussed about index register. So it is also used for addressing, index type of addressing. L is linkage register. When you are using this jump instruction, that is R sub, J sub, when you are using this jump instruction, so where you are going to jump, that details will be stored in the linkage register. Then we have discussed about program counter. Program counter is a register which contains the address of the next instruction to be executed. Then status word, that was we have discussed as when you are testing a device and if the device is busy, free or not. When you are testing that device, you will get a value less than, equal to, greater than. That details will be set in a condition code and it is denoted in the status set. This we have discussed for SIC, but here the registers are BSTF and B is a base register, S and T are general purpose registers, that is they don't have any specific purpose as we have discussed for the previous 6 one, accumulator, index register, linkage register, program counter, status set and even base register has some purpose, but these don't have a specific purpose. It is just used for storage. Then the last register is F. So in the previous class we have discussed about SIC. SIC will support every operation. Since the memory is very small, we don't support floating point. But here in SIC XE, it is upgraded in such a way that it supports floating point operation. When it supports floating point operation, you need a floating point register also. For that we are using F. So 4 registers, base register, S, F, ST and F, BSTF. So B is used for base register and F is for floating point accumulator. Then S and T are general purpose registers. Hope you understood registers. Next we will move on to data format. See, SIC XE supports all the operations of SIC also. So data formats, if you compare SIC, when you think about SIC, what are the data supported by SIC? SIC supports numbers which is represented by 24 bits. SIC support negative values also. How is negative value represented? Negative value is represented by means of 2's complement. Then alphabets are represented by means of 8-bit ASCII code. SIC XE also does all those things. In addition, SIC don't support floating point, but here SIC XE supports floating point. What is floating point number? Floating point number means the number that is between 0 and 1, not between 0 and that the values that has point values. For example, 22 by 7, the answer is 3.14. That is a floating point value. Clear? So floating point number, and the floating point number, it is represented in 48 bits. The total memory is 48 bits, or the total representation is 48 bits. It is divided into three things: S, exponent and fraction. S is represented in 1 bit, exponent in 11 bit and fraction in 36. 36 plus 11, 47, 47 plus 1, 48. This is how floating point value is represented. The maximum value you can represent in is, it is given by the formula fraction into 2 power exponential of exponential minus 1024. This is how a data format is represented. So next we will move on to instruction format. So the last SIC, it has only one type of instruction format, but here in SIC XE, it has 4 types of instruction format. Format 1, format 2, format 3 and format 4. So what is format 1? See, format 1 is represented by 1 byte. 1 byte is what? 8 bits. Format 2 is represented by 2 bytes or 16 bits. Format 3 is represented by 3 bytes or 24 bits. And format 4 is represented by 4 bytes or 32 bits. So that is how it goes. And format 1, see, format 1 contains, so the format 1 contains only opcode associated with it. Format 2 contains opcode and registers associated with it. And format 3 contains an opcode and some addressing related to it. Format 2, 3 and 4 has some addressing related to it. See, the instruction formats and addressing modes will be explained in detail in the next class. So here we will be learning only this thing. In detail we will discuss in the next class. So we have 4 instruction format 1, 2, 3 and 4. Format 1 contain 1 byte instruction, format 2 contain 2 byte instruction, format 3 contain 3 byte instruction and format 4 contain 4 byte instruction. Clear? So the structure is given. We will discuss in detail in the next class. The next one is you have some addressing mode. So what is addressing mode? Here you have I'll tell the addressing modes. The addressing modes are indirect addressing mode, immediate addressing mode, then base relative addressing mode, program counter relative addressing mode, then you have indexed addressing mode. So these are some of the addressing modes. We'll discuss in detail in the next class. So next one is instruction set. What is the need for instruction set? When a computer has to do some task or it has to perform some work, what does computer do? The computer needs the help of an instruction. So instruction is nothing but it is the structure that instructs the computer to do some work. So only when you have some instruction you can do some operation. So we have discussed about some instruction already, that is load and store instructions in SIC are LDA, LDX, that is load into accumulator, load into index register, store into accumulator, STA, STX. Then we have discussed about arithmetic operation like add, subtraction, multiply, division, MUL, SUB, DAV, we have discussed that. Then you have had a compare instruction. Then you have jump instruction like R sub, J sub. J sub means jump to subroutine. What is a subroutine? Subroutine is nothing but that is like a function. That is, a program will come from line first. It will go sequentially. At one point, if the program has to jump to some other place, it is represented using jump subroutine. Then we have discussed all those things. Now we are going to see some instruction sets used in our SIC. You had a new register called as base register. So it will also have load and store instruction. The load and store instructions are LDB and STB. LDB means load into base register. STB means store in the base register. Then the next one is floating point arithmetic. What is floating point arithmetic? That is, you have to do some floating point operation. Add the two floating point numbers, that is add F, subtract the floating point number sub F, multiply the floating point number MULF, then division of F. So these are the instructions used for performing arithmetic operation using floating point. Then RMO, that is register move operation. Then register to register arithmetic is supported, that is add R, subtract R, that is two registers. You have a register like linkage register and you have a register like base register. If I want to add the values, I will give ADDR, that means add in the register, X, L, comma, B, that means I will add both the values from both those registers. Then next one is supervisory call. What is supervisory call? Here you have a concept called as interrupt. What is interrupt? For example, now listen, I am teaching this, I am taking class here. Suppose another work comes. For example, my mobile phone is ringing. That call is from, suppose the call is from the mobile phone provider. That is, they will be asking us to set ringtones and all those things. Some advertisement call has come. What I will do? I will just ignore the call because that is not an important work for me. But what is interrupt? That means some other call comes which is an important call. For example, an important person calls me. For example, maybe our chairman calls me. What I will do? So I will cut this, I will stop the video recording, I will go there, I will attend the call, then I will come back and I will continue this. That is interrupt. Interrupt means a higher priority process. Process means work that is carried out. When a higher priority process comes or when a higher priority job comes, we will stop the current job and we will go for continuing the next job and we will come back. Yes, this is supervisory call. Here in SIC, it supports supervisory call also. That means when an work is taking place, if some other important work comes, that has to be given the highest priority. If you are giving highest priority to this, that is done by supervisory call. Understood? So the instructions are, that is load and store instruction, then arithmetic operation, then move instruction, move from one register, then register to register arithmetic, add R, subtract R, multiply R, divide R, then supervisory call. Then the last one is input output. So in the previous lecture we have discussed that before performing an input-output operation, what you have to do? We have to test the device. If you have to check whether the device is free or not, because the device can perform only one operation at a time. The device cannot perform more than one operation at a time. When a device cannot perform only more than one operation at a time, what will the device do? It will perform when it is performing one operation, it cannot do another work. So obviously you have to test the device whether it is free or not. First operation is testing the device. Why we are testing the device? Because the device can perform only one work at a time. So we are testing the device. If the device is not free, we have to wait, and again you have to test the device. When the device is free, we will go for reading the data. Then when you are writing the data, again you have to go for testing the device. Whether if the device is free, you are going for writing the data. Here the input and output, for input and output you have I/O channel. That means for performing input and output we have a different channel. Other operation will be performed in another channel. Specifically for input and output you have a different channel. The different channels. So when you have a different channel, so what you have to do? You have to start input out. First you have to test the input output channel whether another input output operation is taking place or not. If another input output is not taking place, you can go for start the input output, test the input output. Then once it is free, you can go for start input output. Then there is another operation called as halt input output. That is, once the input output operation is over, you can go for halting the input output. So input from SIC and SIC-XC, the difference is there every operation is performed by a single channel. Here you have, for performing input output, you have a different channel. In that, what we are doing? So in that we are performing input output in a different channel. So you have to test the input output channel. If it is free, you have to start the input output. If it is over, you have to halt the input output. So in today's class, we have discussed about simplified instructional computer extra equipment, that is XC, which is an upgraded version of SIC. So what we have discussed? We have discussed about the memory. Memory was upgraded from 2 power 15 to 2 power 20, which is 1 megabyte. Then we have discussed, that is, we have additional 4 registers. They are B, S, T and F. Base register, S and T are general purpose registers, and F is what? F is nothing but a floating point accumulator. Then we have discussed about data format. 48-bit is used to represent floating point numbers, S, exponent and fraction. S is represented by 1 bit, exponent is represented by 11 bit, and fraction is represented by 36 bit. Total you have 48 bits. Then we have discussed about the formats. Format 1, 2, 3 and 4 and addressing modes, few addressing modes. So those things will be discussed in detail in the next lecture. Next we have discussed about the instruction sets. The instruction sets are load and store instruction, the 2 load and store instructions, that's LDB and STB. Then we have discussed about floating point arithmetic. Then we have discussed about register arithmetic, register move operation, then an interrupt to the OS by SVC call, supervisory call interrupt. Then we have discussed about input output, where we have a different channel. That is, for performing input output, you have a channel, that is I/O. So you have to test the I/O device whether it is free or not. If it is free, you have to start the input. If it is not free, you have to halt the input. That is about today's class. Hope you understood. Thank you.